Now for our last video, we are going to learn how to handle the spikes. One thing we should point out is that when doing any of your calculation, whether it is the concentration, whether it is the spikes, the duplicates, the blank spikes, we always assume that our final volume is 16 milliliters. The volume in the digestion tube was 24 milliliters. Everything is made up to a volume of 16 milliliters, and then we add 8 milliliters of digestion solution. Since we add 8 milliliters of digestion solution to everything, when the calculation is over, we would then have to subtract 8 milliliters of digestion solution. So rather than add the 8 milliliters in for the purposes of our calculation, and then have to subtract the 8 milliliters out for the purposes of our calculation, we just ignore that 8 milliliters and treat everything as being made up in 16 milliliters. Now, a spike solution contains a contribution from our sample, in this case CR5, and a contribution from our spiking solution, in this case 10 milligram per milliliter per liter standard. So, how many milligrams from CR5? Well, in this case, we started with 12 milliliters of sample CR5. So we know that 12 milliliters is 0.012 liters times 5.1 milligrams per liter, or 0.061 milligrams. Next up, how many milligrams of phosphorus from the 10 ppm standard? And that is 4 milliliters of standard, or 0.004 liters, times 10 milligrams per liter. Now, in this case, we are doing a 12 milliliter of the sample and 4 milliliter of 10 part per million standard, but the math works the same regardless. And we get 0.04 milligrams. So what is the final concentration in the digestion tube? Well, we are going to take milligrams plus milligrams, divide by liters, and the final volume in the digestion tube is 0.016 liters, or 16 milliliters. Now, if we wanted to, we could add the 8 milliliters of digestion solution, and then at the end of this calculation, subtract it back off. So let's skip those steps and just work with 16 milliliters. And that gives us 6.32 or 6.33 milligrams per liter in our spike solution, and we measured 6.99. So we'll take the measured amount divided by the theoretical amount and get a spike recovery of 110%. Now let's do the same thing for our blank. In this case, we took 12 milliliters of water, 0.012 milliliters times 0 milligrams per liter, or 0 parts per million. And we had 0.004 liters of standard times 10 milligrams per liter. which we're now going to divide by 16 milliliters, and we get 2.5. So we now take what we got divided by what we put in, and that gives us a blank spike recovery of 101.73%. We can now take our samples, all of our results, and we can cut and paste them onto the next page, which we call for the report. And so we then we paste values and the number formats, and there is our final report. There is our data ready for release to the client. And we'll save that, and we'll stop the recording. Thank you for watching.